This video abstract presents the article, Analysis and Evaluation of a Boost Converter with Power Processing Reduction for Photovoltaic Applications, submitted for publication in the IEEE Latin America Transactions. The authors are Iván Reyes, Jorge Morales, Saúl Méndez, Ulises Muñoz, Claudia Rivera, and Dora Castro. The proposed converter architecture reduces unnecessary power processing by enabling a partial power flow directly from the PV source to the load, while only a fraction of the total power is handled by the converter. This approach increases the overall efficiency of the system and enhances its suitability for a variety of residential, commercial, and energy storage applications. In this research, the characteristic waveforms during a switching period were analyzed, highlighting the current and voltage variations across the main elements of the system. From the steady-state analysis, the operating points of the converter and the gain relation, directly dependent on the duty cycle, are obtained. Two operating states of the converter are shown, when the switch is on and when it is off. From these modes, the equations describing currents and voltages are obtained. Using them, the average model is derived, treating the duty cycle as a continuous variable. Additionally, an analysis of the partial power processing in the buffer element was carried out, which directly increases the overall efficiency of the system. This analysis was performed using Volt-Ampere VA area modeling, allowing the identification of the operating regions as a function of the duty cycle, which contributes to improving the design of the converter. The experimental voltage and current measurements obtained from the boost converter are presented, validating the theoretical results. Additionally, the partial power processing in the buffer element is analyzed, confirming its contribution to improving the overall efficiency of the system. Finally, the closed-loop experimental tests are presented, along with a dynamic response under load variations. These results allow evaluating the controller's performance and verifying the converter's stability and regulation capability under varying operating conditions. In conclusion, this research presented the analysis of a boost converter with reduced power processing, along with a design methodology and a study of partial power processing. Numerical analyses and experimental tests were conducted to validate the obtained results, complemented by an evaluation of the system's overall efficiency and final remarks on its performance.